So first the data format should be made like this. So the first one I have kept blocks, then season, then genotypes, followed by all the traits. So here for example the checks are genotype 1 and 2. So genotype 1 and 2 are the checks present in block 1 for the season 1. So I'm just highlighting like that. So same thing, same checks are repeated in the block 2 and then followed by the genotypes. So this I have done for 3 blocks. So totally there are uh, 2 checks and 9 genotypes, so making them totally 11 genotypes for this experiment. So this is the data for season 1 and this is the data for season 2. So as said, so here there are totally 9 genotypes and 2 checks. The order I have made like 1 and 2 are the checks. So 1, 2 are the checks, followed by the genotypes 3, 4, 5. This is the first block, first season, followed by the second block, first season, the checks 1 and 2, then the genotypes. Likewise I have made for the second season also. So this is second season, first block 1 and 2 are checks, 3, 4, 5 are genotypes. Then the second block 1 and 2 are checks, 6, 7, 8 are genotypes. Likewise second season. So this is the data for the augmented design when we have 2 seasons. So similarly any other designs also can be made, like suppose sometimes when we have replications from alpha lattice design, so we can have replication, and same thing, replication 1 will be there, and then replication 2 we can add. Likewise we can add for replications also. So then the data will be little more extra. So for any design, augmented design, alpha lattice, or even for simple RBD where you have multiple seasons, their blocks will be not there for RBD. So likewise for each this is like a basic data frame. So depending on our design, our data frame can be adjusted. Sometimes we will have 2 season in one environment, so that time season 1 and 2 will be there. When we have two different environment, we can have another one column category as environment. Sometime when we have 2 years, we can have years. So years will have first year. In first year we'll have 2 seasons, in second year we'll have 2 seasons, or sometimes in second year only 1 season. That data also can be made, but this is the general data frame. In this we can accommodate our data as per our how we have grown in the field. So here we should make sure we are not having any spaces in the data file. So when we write, this is like say silking length, so we do not leave space. So if we leave space, that it will be problem. So everything should be continuous letters. Most of the times when we give abbreviations in very short form, it is very easy. So block, season, genotype, like that, no spaces. If you give genotype number like that, then we'll have a space, that will be a problem. So like this we will form the data frame. So what next we'll have to do is we have to create another Excel sheet. So I have made it already. So we have to make a blank Excel sheet with the like you can give any heading name. So this is genotypes, I have just kept gen and 1 to 11. So totally we have 11. So I have made it 11, and we have to save this also in the same place where we have stored the data file. So both this file I have saved in my F new volume. So this is the data file, so that I have labeled it as 11 gen, and this is the empty data file which doesn't have any like say nothing, only the genotype names are there. So 1 to 11 is there, like that. So these 2 files should be needed for the further BLUP analysis. So this is the script for LMV4. So first we have to install the packages. After installing, we will run the library. So that is, so if you don't have the package, first you have to click the packages and then install, and then here we can type the package name LMV4. So and then we will click install, it will start installing. So once the packages are installed, both LMV4 and DPLYR, we will run them as library. So we will run the library LMV4, which we can see here. It is it has run library. Next I am running this deployer library also. So I am running both these libraries. So now I am setting the working directory where all the files have been stored. So set working directory in F folder, in opt in F volume opt folder, BLUP folder. So 2 folders are there. So I have set the working directory. Now I will import the data. So now I will import the data file. So I'll go to import dataset, and then from Excel, and then browse. So here, that is the folder which we had, new volume F, in that opt folder, BLUP folder. So these both we need to import. I will import them one by one. So 11 gen I will import, give open, and here import. So I have imported this one. So I will import the next one also. Again import from Excel, browse, G, and then open, again import. So I have imported both these files. Again I'll go back to the codes. So now I will give a new name for the data file I have created. So we can save our data file in any names. So that name we can change here. Since I have saved it as 11 gen, the file has come as x11 gen. So since it is starting with number, the x has come. So when we save directly as genotype something, we can directly give the name, that x need not be written. So now I am giving a new data file df, so that all the analysis we need not change our data file name every time. So this will be a common one. So I'll run this one. So once I have run this, now our new data file name will be df. So I'll give the structure. We can see how it looks like. So here down we can see, so our data file has blocks, seasons, genotypes, and followed by all the traits. So we have totally 30 data points for each rows. So now what we have to do is we have to set the genotypes, blocks, and season as factors. So if we give the genotype name itself, like say any name, if we give like a Rasi, like that genotype name will remain as factor. But here we have given numbers, so we will follow the number, so that it is very easy to do. If you follow the genotype's name, even a small error will give error. So it is better to follow the number. So since we are following numbers, we have to set the numbers as factors. So here first we'll set the genotypes. So df is the new data file name, then genotype is the heading of our genotypes what we have given in the data file. So df genotype as dot factor df dollar genotype. So this will make our genotype as factors. Then we will do the same thing for blocks and seasons. So if we have given different names for the headings of genotypes, blocks, and season, that name should come here. So instead of genotype, some of us can write G. Instead of blocks, we can write B. So in that case, we have to change it here. Like if we have changed it there, we will keep blocks as dfb as dot factor, block will be again dfb, and we can run the command. So like that we can do. So now we will see this structure again. So previously we have done this structure. We can see all our blocks, season, and genotypes are in numbers. So now after we have set them as factors, we will see the structure. So the structure now we can see the blocks, season, and genotypes have turned into factors. So here there are the blocks has 3 factors. That means we have 3 blocks. So that is what it has understood. And season we had 2 seasons, and genotypes we have totally 11 genotypes. So so this will be easy for the system to analyze, and all our numerical data, like others should be numerical. Again here if we have any non-numerical data, it will show as factors or characters, something like that. In that case we have to put that character. Say for example our silking length has shown any character or like that thing, then you have to keep as SL is equal to as dot numeric and like that. So if we run the command, that will again become numeric. So if at all we don't have that problem, we can continue like that. Okay, so then what we are doing is, so we have created another one empty file with only the total genotypes number. So if we are not knowing what is our exact genotype number, when we have very large number of genotypes, sometimes only few checks will be in first season, in second season we'll be having more checks, some checks will be missing. So that time our genotype number will be of confusion. So once you have run this structure, we will know what is the exact number of the genotype we have. So we have 11 genotypes. So when we have in large number, we will know it here, it is 300, 350, whatever. So that exact number of genotypes you have to set in the empty data frame. Like so here we have only 11. So I have set the first one as the heading, that is genotype. followed by 1 to 11. So if you have 300, 400 or whatever the number, we have to create that many numbers and we have to save it. So we have imported it already. So if you have not done that time, if you, any error is there, we can check here and redo, import it again, and here we have to change that number, whatever number we have. So here we have only 11 genotypes, so I have kept it as 11 as such, and we can run this command, and then followed by that we have to run all these commands. So this will, why we are doing this means, in that new empty file which I have created, all these data files will be means all these points will be added to that. So we need not worry about this, just we can run the commands as such. So here if we have different number of genotypes, again we have to change. Here I have given 11, so if our genotypes are more, we have to change this. Other points we need not change. Again see here, entry I have given as third. So entry means our genotype name in the original file is third place. If you are giving genotypes as first place, here it should come as comma 1. So if you are not doing any changes from the points what I am saying, you can follow simply all these things and just run all these commands. So again, this is for other calculations like heritability and other variance components. For that we are creating these files along with this. So we are just running this, and then now we want to see all the column names. So what are all the columns present in our data files? So we have blocks, season, genotypes, followed by the traits. So for running the analysis, it doesn't need the blocks, season and genotypes, only the other traits alone it needs. So we need to start from the fourth column. Sometimes when we have replication extra or environment extra, then it will come more, like say we will have an environment here and a replication here, so it will become 5. So in that case our data file will start from the sixth column, but in this case it is starting from fourth column. That's why I have given it as 4. So I am giving it as 4. We can run it, and now we can see what are our how will our final analysis file will start from this anthesis number, that is from the fourth column. So likewise we can check it, and we can give from 4, 5, or sometimes it might be from 3 also. Like that we can change it here, and then we'll give this command. So we are giving a new file, means column number, a new file name, column number, so that the analysis will be performed only in this short new file. And then we'll give it I is equal to 1. So I will explain this all this together. So here we have totally 12 traits. So starting from AN to granule, so there are 12 traits. So I have given 12 here. If we have 10 traits or 5 traits, we can change it accordingly here. So it will start from first column, that is from anthesis number, to granule, that is 12th one. So we can change here. Every time it should start from 1 only, since we have created the new small file. So it will start from 1 to the 12th trait, or any number of traits which we want to analyze. So that will be here, and other things we need not change, whatever. The main thing we have to see is the model. So in the model, what we have to do means we have to create a model. So y is the final data file or the final BLUP value which we want. So that is based on the genotype. So if we have this 1 and this dash sign, it means that is random effect. If you want to have the genotype as fixed effect, we will remove this 1 and dash. So here depending on, if we use land races, we can consider the genotype as random effects. If we have a developed variety or a fixed line, we can call them as fixed effects. So in that case we will need not have 1 and dash. So since this data file is from segregating population, we are considering it as a genotype also as a random effects. So we will give this code as model is equal to LMER, while this one we will just change whatever is made here. So we have genotype as random effects, followed by blocks as random effects, season as random effects, and then genotype into environment interaction, that is genotype into season in this case as random effect, followed by our data file. So these and all we need not change J1 whatever is there, because everything I have explained here. We can read it there. So if at all we have an extra effect, like as I said earlier, if you have an environment, then we can put one more plus here and add it as environment. So I'll copy this simply. So I'm placing this, and we can have environment, or sometimes we'll have replication. So in that case we can have an extra factors replication, and sometimes we need not need this genotype into season effects, we need only genotype into environment effects. So that time we can have environment. Likewise Likewise, we can have all the combinations or all the things which we want to include here. This we have to decide based on our design on the model. So now we once we have decided the model, then we need not change anything here. So that much is to be explained from here. We need not change anything, just we will run from the starting. So this will run in a loop for all the threads. We will select from for and go down till, so we have to keep till this arrow and run the command. So this will run, so and we can see the so this will run here and we can see all the it is run without any error. If there are any error, it will show. Here we don't have any error, and it will give the some of the plots also. Here the data is very small, so that's why it's giving in like a single histogram. So I will show it for this will come continuously for all the 12 threads. So this will be the 12th thread. So we can copy and save it in a PowerPoint just like that. We can copy the image and save, or we can export it as image also. But the names will not come. It will come as BLUP, 1 only. It will not come the thread names. So we have to edit it in again. So I'll delete for each thread. So this is the 12th thread. Likewise, this is for the 11th thread. So for the 11th thread, some value is there. So it's coming like that. So if you have a big data file, the proper distribution will come. So likewise, for each thread, we can go back and take the file also. So like this is for anthesis number. So here we can see like somewhat a proper distribution from even from a small thing. So we can copy this, paste it in Excel and write our name, and after that we can delete this first one, so that we'll go back to the next thread. Likewise, we can take the pictures. So now we have to export our BLUP files. So I will run this data output, and then followed by that we can save our data file in this write.csv command. So I will paste the like what to say, the exact location where it needs to be saved. So in the F folder, followed by this this symbol, followed by the slash op. So we have to be careful when we are writing this code. We have to be following the same commands, and then what our file name should be saved as. I am saving it as combined blup.txt. So any name we can say. We can edit the name here and the file location as we have. So we'll keep it here and run this command. So once we have run this command, our file will be saved. So I'll go back to that folder, BLUP folder. So now we can see combined BLUP, the result has come. So we can open this. So we can open this in Excel format. We can directly open. So it has opened in the Excel file. So to view it properly, we can go to this data, and then text to columns. First we'll select the first column, and then we'll go to data, text to columns, and then here we'll go to next. So here we have to select this others, so others, and then we have to give this comma. So this will be CSV, so it is comma separated. So wherever the comma is there, it will change the position. So and then give next, and then finish. So now we can see the analyzed data of all the genotypes. So these are the comments which are unnecessary. We can remove them. So I will remove them, delete them, and then now we will have all the 11 genotypes, and these are the BLUP values. So here we can see they are having a very narrow range because we have done with very small number of genotypes. But for other traits, some other traits, we can have the we can see the differences. So now we will know that 1 and 2 are the checks. So and other things are the genotypes. Now we can replace the numbers with the genotypes, and we can do further analysis. So this is the BLUP results. Now we will see how we will do the other variances and all. So nothing, we will just run these commands. Nothing much to explain here. So all the commands are there. So we have run now till the write.csv format. So after that, only things to be changed is this number of observations. So that is n LOC we have given. So we have recorded 2 observations say per genotype in a plot. So that's why we have given 2. If you have recorded 5 plants per genotype, we can give it as 5, or 10 means 10, whatever we have recorded, that number we'll give here. So other than that, nothing to be changed. So from here we can directly run all the commands. So this will calculate the heritability. That's why you want to give the number of plants we have taken the observations. So we can run everything. So till the last we can run, and then give run. So yeah, then finally we can save the output. So here there is a small error, so I'll fix it and send it back. So here it is j, it's not j, it will be df. So it should be df. I'll do it again. So from here, now it has run. So we can save the file again as csv. So write as csv again, the same folder which you have pasted, and a new data file name. So this will be combined BLUP summary we can save. So this will give the variances and all, and we can run this one, and we can go back to the folder. So we can see the combined BLUP summary, same like the previously said. We can open this in Excel file, and then we can select the first column, go to data, text to columns. Next you have to select the other, give comma, and then finish. So now everything will come. So these are all the 12 traits which he had. So this is the variances of genotype into environment or season. This is the variance of genotype. This is the variance of blocks. This is the variance of season, and these are the error variances, and these are the heritability and covariances of genotype, and this is the minimum value, this is the maximum value, and mean, and all those things. So we can have this for any other analysis. So this can be these things like from trait till the residual. So this can be used in place of ANOVA, except here we will not have the proper degrees of freedom. Otherwise these are the same variances like the variances which we will get in the ANOVA table. So we can use it in place of ANOVA. We can have here and say their significance or not, like that. Approximately we can say from the values by comparing them with the residuals. We can say whether they are there is a variation between the genotypes, or variation in the season into genotypes into genotype into environmental effect, there is significant difference, or within the blocks there is difference or not. That kind we have to see and say. As like ANOVA we cannot have a proper significance, but comparing with the residual we can say the differences. So that's the analysis is done. So yeah, that's all. Thank you.